Well, I'm doing this on a Monday morning, and I guess Monday morning is when they cut the grass out there. And they're also working the paving of our lot across the street. So we have a little bit of noise, but let's see if we can just continue. Now, here is where they actually ask us to go over at least the first two formulas. That when you have an equation in two variables, like so, and it equals a constant, this is called standard form of the linear equation in two variables. And as I mentioned before, if you solve for the letter y, you end up with y equals something like this, where m is your slope and b, from an earlier lesson, is your y-intercept. Then later we'll be going over slope, we'll be going over point slope. And these are special forms. They're standard forms, but in this case it's for a horizontal line. And this one a vertical line. So these are all things that we're going to be going over as we cover items in this section. And this is section 2 of chapter 3, which deals with graphing. And here we're going to graph linear equations. And the first thing they'd like us to look at is something a linear equation? Well, it is when you draw the equation, is it a straight line? And the key is, as long as the exponents on your x and y term in the numerator are a 1, remember we went over this back in chapter 1, we said there were exponents only to the first power. This is linear. So the ones that are linear, I will underline. That's linear. And by the way, this one is in standard form. X, y equals a constant. Now again, our exponents here are a 1 and a 1. And this is in slope-intercept form, and that is linear. But as we look at example C, we see we have a y to the second. Our exponent is not 1. So this is not an example of a linear equation. Notice D is on our little reminder section over here, and it happens to be formula 6, which is a vertical line, which is a straight line, so this one is linear. Now if you were to have something like this, y equals, let's say, k over x, where the exponents are only 1, but here we have x in the denominator, that's not a linear equation. So as we go on to example 2, there's an equation in standard form, and the general procedure for making a graph of this is to first make a t-chart and then put some values for x in your t-chart. Okay? You might say, well, how do I know -1, 0, 1? Well, I want to pick values near the origin so it doesn't go way off our graph. And when you have fractions, there's a little different technique, but often these are good numbers. So let's work them out. If x is a -1, this becomes a -2 plus y equals 5. Transpose that, and this gives you then a 7. If x is 0, y is 5. If this is 0, you just put a 0 there, y is 5. And if this is 1, this becomes a +2. And when we transpose it, it becomes a 3. So we now have 3 values, and hopefully we've done our arithmetic correctly. We're now going to graph. So we have a -1 and a 7. So a -1 is right here. This is 5. So 7 is about there. Then we have 0, 5 right there. And then we have 1, 3. 1 is there, and 3 is about there. Now I do have actually a ruler that I brought in for stuff like this, because when you use a ruler, you do get nice lines. And that works out then very well. So the technique again that we'll be using a lot will be to make a T-chart, basically a T-chart, X and Y, select some values, put them in your equation, this is in standard form, and get your corresponding Y values, plot it, and they should be in a straight line. As we go on to example 3, notice that this is in standard form, and I'm going to show you something that I think will be very useful, and that is this special T-chart. This is called the X and Y Intercept T-chart. And why is that? Well, because when you put a 0 there, whatever this term is, that will be your B. And we said that's where it's going to cross the y-axis. If you put a value here, 0, for y, this value, that will be your x-intercept. So we'll see that. Let's just watch this. So if x is 0, x is 0, what will y be? 5. And if y is 0, what will x be? A -3. I hope I didn't go too fast. This is 0. -5 times 0 is 0. So you're just going to solve that. That gives you 5. And if this is a 0, that becomes a 0. Divide both sides by a -5, you get a -3. So we now have 2 points. This is your y-intercept, we said. It's where the line will cross the y-axis. So it's going to be 1, 2, 3, 4, 5, a dot right there. And this is going to be a -3, 0, so 1, 2, 3, right there. And we take our ruler. So we want to really make this snazzy here. And notice, it's going through the y-axis there. This is 0, B, your y-intercept. And this is A, 0, your x-intercept. And how did I get it? I got it by putting this special T-chart where I have a 0 here and a 0 there. And then when I find that, if it's in standard form, a really good tool for graphing. Because now as you take your graph in MATLAB, you're going to put a dot there, click it, go up to here, click it, and there are your intercepts. Now sometimes they're going to say they want you to solve it by finding the intercepts. Well, what are the intercepts? Well, the intercepts are the y-intercept and the x-intercept, and you find it using this T-chart, especially when it's in standard form. Now you recall we did give you a little hint of this in section 1. But again, we're just using our standard t-chart. If x is a -1, 3 times -1 is -3, so y equals -3. If x is 0, y is 0. And if x is a +1, y is 3. And we'll graph these in a minute. Now here it's a little different when I set the t-chart up. I didn't use a -1 and a +1. Because of the fraction, I chose multiples of my denominator. So I'm going to use a -3, so the 3's cancel out, and I get whole numbers. So this is a case where we don't use these, but we specialize it so that we can work with the fraction that's there. So here, this is going to be a negative times a negative will give you a positive. The 3's cancel out, and you end up with a 4. This becomes a 1 plus 3. Here, if this is a 0, this just becomes 3. And here, if this is a +3, this becomes a -1, and a +3 gives us a 2. So as you sketch these, sketching is different from actually plotting, because the grid lines are not going to be accurate, but you want it to do the best you can. So there's our graph, a -1, -3. So -1, -3 right there, 0 right there, 1, +3 right there. And you use your ruler. And there's your graph. Now remember, these have arrows at the end, and there's an infinite number of points. We just picked 3 out to give us a good straight line. And the same thing here. A -3, 4. So 1, 2, 3, 1, 2, 3, 4. About there, 0, 3, and 3, 2. 1, 2, 3, 2. And again, we get a nice line. Off just a little bit there. In example 6, we're seeing an interesting modification of equation 2 where y equals something. In fact, we're calling that a special case, equation 5, where y equals b. So whatever is in this b position is your y-intercept. And your y-intercept is a -2. So if y is always going to be -2, it doesn't really make any difference what you put here for your x values, because y is always going to be -2, and that creates this horizontal line. So anytime you have an equation, y equals a constant, that is going to be your y-intercept, and you just make a horizontal line through that point. Now as we look at this one a little more closely, we see y equals 3x plus 6. Now we recently did y equals 3x. Now when we did that, you notice it went through 0. Our y-intercept was 0. And it looked like this green line. When we put the t-chart and these values, we now get the red line. And it happens to be parallel to the green line, except, and notice that we said B up here is the y-intercept. It's going through the y-intercept value of 6. So there's your y-intercept there. There's your y-intercept there at 0, the origin. And since these lines, in the case of M here, again, we're just showing you a little bit of what's going on. This happens to be the slope of the line. And we know the slopes are the same, so that's why these lines are parallel. Again, we're breaking into some of the things. I'm giving you a little preview of what's coming up. Okay, as we go into example 8 here, I'm going to introduce a couple of words: interpolation and extrapolation. I have heard of these, but this deals with registered nurses are increasing at a rate of about, these are in thousands, so 58.1 thousands per year. And when we started, we had this amount. Now notice this amount, when we put a 0 in our chart, happens to be our y-intercept. So anything over in this position, when we're using equation 2, is our y-intercept. And all we then do is, as we get years, 1 year, 5 years, we put in the numbers. I've made up my scatter diagram, and this is the data we have, let's say up to 5 years. But suppose we want to predict. Now, when we predict, it's going beyond our known data. But if that trend continues, we can indicate it with a dotted line, as I have here. And if they want to know it 10 years from this, we would put a 10 there, put the 10 where X is, add these together, and then we end up with 32,000. And that's extrapolating beyond our known data, following the trend. And this is how you do it. And that's what it looks like. Okay, again, you're going to do some practice, the quiz maze, as we get ready for our next topic, 3.3.